Hello everyone, how are you? In this video, I am going to guide you how can you create a program which can understand document using the Gemini AI and Python. We are going to see how to understand the PDF docs, basically how does the model will understand our PDF documents, how can it extract the information and the information how it can be structured. We can load our PDF file from a URL or from local files. And we are going to see how to deal with small sized PDF and large sized PDF. And when we say small, under 20 MB PDF can be considered as small for the Gemini AI and over 20 MB will be considered as large. So both have different methods to deal and upload that file to Gemini AI for processing. So let us get started in our file document processing.py. So first of all, we are just going to import the Gen AI module. So we can say from Google import Gen AI. Now, first of all, let us see how can we fetch a PDF file from a URL and give that PDF file to our model and ask that model to summarize that document. So I have a document URL, or basically I can say I have a PDF URL, and this PDF URL is what you can see on the screen. Doc URL is equal to this URL which contains a PDF. So before we have this doc URL, let us actually create our Gen AI client, the Gemini client. So we can say client is equal to Gen AI dot client. Now we need to load the PDF which is there in this particular URL at this particular URL, right? So first of all, we need to actually get the PDF at this particular URL and fetch the byte data from this particular URL, and then we are going to encode this PDF byte data. So before we do this, let's import a module called as import httpx. Using this module, we are going to make a request to this particular URL and fetch the PDF. So we can say doc underscore data is equal to httpx dot get. We are going to make a get request to this particular URL. The URL is doc URL, and then we can say dot content. So after it gets the response, we are going to fetch the content. So basically, this is going to give us the PDF bytes. We can use this PDF byte and send this PDF byte to the Gemini model to analyze and summarize the document. So next is, let us create a prompt. Let us say the prompt is equal to summarize the document. So we are going to send this document and ask the model to summarize this. So we can say response will be equal to client.models.generate content. We are going to generate some content. The model we are going to choose is the Gemini 2.5 Flash. The contents we are going to send this particular model is actually going to be two different data. The first data is going to be the PDF and the second data is going to be our prompt. So we can say prompt. Now we have the document data as a bytes, right? We need to fetch this byte and convert it to something which we can send as a PDF, right? Now to send any document information to the Gemini model, we need to send this as part. Now this part is available under the types. So we need to import the types from google.genai import types. Now we need to convert our document data to a part. So we can say the PDF will be equal to types.part. This should be types, not type. So types.part. And since our data is a byte, we need to say dot from bytes. We need to create part from bytes. And this byte has the data which is equal to doc underscore data. And the MIME type of the data is application PDF. So we are sending a PDF, right? So the MIME type is going to be application PDF. So we got our PDF. We can send the PDF here. And we are saying that, hey, Gemini, I'm sending you a PDF and I'm sending you a prompt. The prompt is summarize the document. Please summarize the document at this particular URL. So our code looks good. We just need to print the response. So we can say print response dot text. Now just to make sure that we are getting a readable type of response and not too big response, let me also send a system instruction. So I can say config is equal to types dot generate content config, and in this we are going to pass the system instruction and we are going to say answer in 200 words, or let us say answer within 200 words. Let's run this code and let us see what's the output we are getting. So I can say python space document processing.py. Let's wait for the response. It's definitely going to take some time because first of all it will have to fetch the PDF, then it will have to fetch the content or the byte of the data, the PDF data, then it needs to convert the PDF to types.part from the bytes, and then it needs to make a call to the Gemini AI model. So it is definitely going to take some time, but no worries, we can wait for the response. So we have got the response, and the response looks good, guys. The response we have got is AlphaFold presents a deep learning based method for protein structure prediction, a crucial challenge in biology. Now we don't need to read the whole description of the document, but what we need to understand is we got the description of the document. Basically, this is our document. I have stored this locally as well, and it is about 28 pages document. It has summarized this within 200 words. So this is one of the way to summarize your document. But right now we are summarizing a document which is at a particular URL. What if our data is stored locally, something like what you can see on the screen? Inside the PDF folder, we have the sample1.pdf, right? Let's do one thing. Let's first update the system instruction and let us say answer within 200 characters so that our response is readable. We are going to read the whole response, and our doc URL is this particular URL, but we are not going to make use of this doc URL to create our PDF. Basically, if you want to use a local PDF file which is stored at a file location in your own computer, then you do not need to change a lot. Your response is not going to change because we are sending the PDF, and even the PDF will be created. Only thing which is going to change is how we are fetching the PDF. So instead of HTTPX, I'm going to make use of something called as pathlib. This can be used to fetch a path. So let me first create my file path. So I can say file path is equal to, it's within the pathlib.path. It is going to create a path, and my path is pdf slash sample1.pdf. So basically, compared to this file in which I am currently at, I had to go to the PDF folder inside which I have the sample1.pdf. So now I have the file path. I want the bytes data. I want the PDF bytes, just like I got it here. I want the PDF byte. So I can say doc underscore data will be updated, and this will be equal to file path dot read underscore bytes. This is going to read my current data or the data at this particular path as a byte. So I have the bytes. Now no logic is required to be changed because I'm creating a PDF using bytes. So basically types dot path dot from bytes, and then I'm getting the response. So this is simple, guys, right? You just need to update the way you are fetching your data. Instead of a doc URL, I'm using the file path, which is stored locally, and then I'm creating a doc data, which is the bytes, but I'm using this file path dot read bytes. Now if I just run the code, I'm going to get a response. So let's run the code. Let's wait for the response. So you can see we have got the response. The response is AlphaFold uses deep learning to predict the protein 3D structures from the amino acid sequences by accurately inferring residue distances. It significantly outperformed other methods in SAS13, providing critical insights into protein function. So the document is analyzed and summarized. One of the concepts you need to understand is how to process large PDF files. Right now, we are doing the processing of PDF files which are expected to be within 20 MB, called as small PDF files. Let's talk about a large PDF file, and let us say we have a large PDF file at a particular URL. Let me copy the URL. So I have the URL here. I can say long context PDF file or a large size PDF file is at this particular location. In this case, you should actually make use of the files API, which is provided by the google-genai module itself. So let's imagine this. We have a long context file path or a PDF path which contains a PDF which is large size. So first of all, I need to fetch that file, right? So to fetch the file, this particular logic is going to be the same. We can say this is my bytes data. We have got our file from a particular path. We need to import one more module called as IO. Let me comment this particular part. Let me comment this particular part and just focus on dealing with long context or long sized PDF file. Basically, the doc URL is now long context PDF path. So here we are fetching the data, the bytes data of the PDF from this particular URL. So these are the bytes, right? Now, instead of directly using this particular doc data in this types.path.from bytes, a better approach is going to be using this IO module. And within this IO module, we have something called as dot bytes IO. Let's pass our byte data within this particular function bytes IO, within this particular class bytes IO. Now what this will do is, instead of saving the file to a disk, this approach is going to keep the data, this particular data, in memory, which can be useful for processing or manipulating the file directly. We basically need to upload this particular file to the Gemini server, and we are going to make use of the files API for this, which is provided by the google-genai module only. And now if you want to create your PDF file, let me actually copy this code. Let me copy this code and comment one of this, and let me take this particular part a little bit down. So now what we have our URL, we have our data converted to bytes IO object, and then we can simply say PDF is equal to, instead of this particular logic, we need to say client dot files dot upload. We can directly make use of the files API to upload our file, and we can say our file is actually equal to doc underscore data, basically this particular data. And we need to do some configuration as well. So we can say config is equal to a dictionary. This should be a dictionary in which the mime underscore type, this will be equal to application slash PDF. This will not be equal to, it should be colon, right? So now we have our PDF file, and let me uncomment the prompt. We need the prompt. So we have our prompt, we have our client, and we have a long context URL, and we have our data. First of all, we are fetching our data from the URL, and then we are fetching its bytes content, and then we are using that bytes content to create a bytes IO object. And now we can directly upload this bytes IO object using the files API, clients.files.upload. This is my file and this is my configuration. Later on, I'm making a request to the Gemini API using the generate content method. And now let's wait for the response. And it is going to take some time, guys, because the PDF size is now big. So you can grab a coffee and come back. I'm just kidding. It is not going to take that much time. It is going to take, I think, 30 to 45 seconds, which is fine. We can wait for that. I will skip some part of this waiting. You are expected to use this process of using the clients.files.upload method when the file size is too big, especially if it is more than 20 MB. So now we have got the output. This is the Apollo 17 final flight plan on this particular date, detailing the mission operations from launch to splashdown. It covers the crew activity, spacecraft systems, launch schedules, consumables, and alternate mission scenarios. So this is how you can process and summarize a document or analyze a document, especially PDF documents, using Google's GenAI module and the Gemini AI model. You can fetch your data from a URL, you can fetch your data from a file path, you can fetch long size PDF from the URL, and this is the complete code for this. So guys, that's it for this video. If this video has explained you how to process a document using this Gemini model, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you do so. And if you have any questions, any doubt, any feedback, you have your comment box. You can do anything with that. Just put your questions in the comment box. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.